What I had done was, how many of you are familiar with a confidence interval? You all took the pre-qual. It's one of the things you had to do in the pre-qual. What's a confidence interval? What do I mean? This is a 95% confidence interval. What does that mean?
That you would be 95% confident that what you're sampling will fall between the two numbers that you end up with.
Let me make it clear. I have a distribution, right? And let's say in the case that we're dealing with, I have a distribution of people, of profits that the people in the bank, that the depositors in the bank are generating. Some of them are generating positive profits for the bank. Some of them, in fact, end up being negative. They're a drain on the bank, right? I would like to calculate the average profit per customer, right? Now, I have the luxury of having all 31,000 plus customers, so that's no big deal. I can easily go down to the bottom of the list, get the mean. It turns out that the average in total was, anybody remember? I did it in class next time.
111.
It was about 111.50. The average for all 31,000 customers was 111.50. The standard deviation was somewhere in the vicinity of $272. Give or take a couple of dollars. Okay? Now, suppose you didn't have the luxury of that. You didn't have all 31,000, right? Or you didn't have time to, it's not that the bank wouldn't give it to you, they didn't have it available, it would take too long to put together. And I want an estimate of that, right? So I tell the bank, give me a sample of size of 100 customers, taken at random. Okay? They will then take the 100 customers, right? And from those 100 customers, I will get the profits for those customers, right? And let's say the average profit for those customers is $90, right? So if you then ask me, what is your estimate of the true mean of all the customers, what would you answer? $90. Remember, I don't really know everything, right? I only know this $90. Is that the correct answer? Is $90 the correct answer? Is that the mean for all the customers?
No.
No, the mean for all the customers is $111.50, right? But you don't know that. So if I asked you give me a single number, you would have to say 90. If I asked you how confident are you that it's correct, I'm not. But what do you want me to do? I don't have anything more. That's if you ask me for a point estimate. The alternative is not for a point estimate, to get a confidence interval. Do your sample, and based on the sample, develop a confidence interval, in this case 95, that will tell me I don't know what the correct answer is exactly, but I am 95% sure that it's between this and this. And they'll give you two numbers. Right? And I showed you here how you construct it. The way you construct it is you do the sample mean, which is, let's say in this case would have been 90, right? Plus or minus 1.96 times the standard deviation, which is 270, divided by the square root of n. N is the sample size. That would be 100 by 10, and you get up with you get an answer. Okay?
It's a 95%.
So this would be a 95% confident. I can say I'm 95% sure. So let me just make up some numbers here. Okay? I don't want to embarrass you, but this was a homework assignment from my undergraduate course in statistics also. And they did it. So I will share it with you. Okay, so let me show you and then I'll explain it. So suppose I told you, so I just said that it's, let's say it's on my sample. Let's say my sample mean was $90. Right? Okay. And the standard deviation based on my sample, was 250. Okay? And I took a random sample of size, let's say 100. Right? Then the confidence interval would be this formula right here. Sample mean plus or minus 1.96 times sigma of the square root of n. So it would be, it would be 90, right? 90 plus or minus 250, I'm sorry, 1.96 times 250 divided by square root of 100, which is 10, right? So it would be 95 confidence I'll get it right. Okay?
Professor,
Yes!
do you mind zooming in again?
Yes, that's exactly what I was going to do.
Thank you.
You're welcome. How about that? Better?
Yeah.
Okay, 95% confident that it's from where to where? So from 90 minus 1.96 times 250 divided by 10, right? To 139. Right? So, based on the sample, I'm hypothetically setting it up. If that would happen, then I took a sample, if I took a sample of size 100 and got a mean of 90, I would say I am 95% sure that the correct answer is the correct mean for everybody is somewhere between $41 and $139. Would I be right? Would I be right or wrong?
At 95% you'll be right.
I am 90, I'm telling you I'm 90. You asked me what my guess is. My response is, I am 95% sure it's between $41 and $139. Am I right or wrong? Why am I right? I'm right because...
Because probabilities.
Why am I right?
Distribution is.
Why am I right?
Because 90 is between
Because what? Because it's 111.50, and that's in that number, in that range. I was right. I created a range. I didn't know it was 111.50. We know it's 11.50. The person who's doing it didn't know. The person would give you a guess and say, based on what I've done, I'm guessing, I'm 95% sure it's between 90, it's 41 to 139. Knowing everything we know, it turns out the person is right.
because of what was the 1150?
Yeah, what's the 1150?
111.50 was in fact the mean of all 31,000 customers.
Oh, you're asking.
Again, one more time. I have 31,500 customers.
I didn't realize we were going back.
Okay, again, one more time. I have 31,500 customers. Those are all the customers, right? I mean, obviously the bank has more, but all the customers, we're not interested in anybody else. Let's say this branch. 31,500 customers. I'd like to know the average profit generated by a customer in this bank, of this 31,500. If I have all the data, which I do, because I gave them to you, it would turn out that the true average customer is generating $111.50. Now, are some of them negative? Yeah. Are some of them generating a lot more money? Yeah. An average is not for every, it's just the average of all the numbers. On the average, each customer in the bank is generating $111.50. I know that because I have all 31,000 customers. My question is, if I don't have all 31,000 customers, what do I do? And the bank doesn't have all 31 on disk or whatever and on a CD. What are they going to do? They'll tell one of the people there, we'll give you randomly selected 100 customers, right? Figure out the average for those 100, right? The person did it and found that the average for the 100 customers that he looked at was $90, right? Knowing what he knows, is that the correct answer? No, it's $111.50, right? It's not $90, right? So that's why point estimates are not terribly helpful, because it's just a shot in the dark. You might have a very high, you might have taken a random sample like we saw with the Bristol bikes or the videos or anything. Your sample can end up on the low side, your sample can end up on the high side, right? But that's the best you can do. No, it's not. That's the best point estimate you can do. It's not the best interval estimate. I can give you an interval where I can tell you, if you don't press me on a single point, but you allow me to give you a range, I will give you a range in which I am 95% sure that the true profit is in there. I calculated it based on this number that I just made up, right? And based on this random sample, it turned out that I am 95% certain it's from 41 to 139. And the question I asked is, did I get the right answer? And the answer is, in other words, did I give you a good approximation of the mean? And the answer is yes. I gave you an interval, and the mean is in that interval. Right? That's the correct answer. The interval is pretty big, right? So it might not be helpful, but the thing is in that it. How can I shrink the interval?
Decrease the confidence.
Right? Let's go back to the formula. What in this interval controls the width of the interval?
196.
This part, the first part, or the second part? The first part says where it's anchored. The second part says plus or minus. Right? So the width of the interval is controlled by this. Is that correct? Can I play around with 196?
Yes.
No. Why not? That's what gives me the 95%. Can I play around with the sigma? No. Sigma is whatever sigma is. Can I play around with the n? Yes. What does n stand for? Sample size. If the interval is too big, what do?
Increase the sample size.
Make the sample size bigger, because the n is in the denominator. If you make the sample size bigger, the fraction will get smaller. So let's go back to the problem that I just did a minute ago, and let's say I got the same thing with a random sample. Let's say I got the same result with a random sample of size 400. What's my confidence interval now? What's my confidence interval now?
Still 95%.
Mine?
Same 95%.
1 sec. Does this change the same or what?
You got the square root
I'm
of
gonna
400.
change.
This has to be divided by 20 now. Right? Because now I'm dividing by the square root of n. N is 400. The square root of n is 20. This now did I shrink the interval? Yeah. Is the mean in that interval?
Yes?
Yeah. And I gave you a smaller interval.
Yeah.
Right? This is a much nicer one than this one. Still pretty large. How can I keep on shrinking it? Raising the n. Right? The right raise. So I can control it, and I can do that in advance. So I can get it now. If it keeps staying at 90, I'm going to have a problem. Right? Because I'm bucking the upper end of this. right? Remember, the correct answer is 111. So when you hear before an election, and people are running for office, so we're going to take polls, okay? Two candidates, A and B. We took 10,000 likely voters, and we found out that candidate A got 52% of the vote with a 95% error of plus or minus 3. Candidate A got 52% of the vote, right? This is in a sample poll with a 95% confidence of plus or minus 3. Translate into English.
49 to 55.
This person, I'm 95% sure that A is getting somewhere from 49 to 55% of the vote. Does that tell me that based on this poll, A is a winner?
More than likely.
No, you can't say more likely. The fact that most of it is in the upper end doesn't make any difference. The answer is no. Too close to call. Can't call it. Because it goes from 49 to, remember in this case it wasn't near the upper end, it was near the upper end of it. You don't know where it is. I'm telling you there's a 95% chance it's between 49 and 92. I'm not telling, and 42 and 55.
49.5.
I'm not, 49 and 55. I'm not telling you that it's most likely no, it's between 40 and 55. I can't declare a winner. How about if I tell you 53% plus or minus 2?
Yes.
I'm 95% sure this person's a winner, but assuming the people who told me to tell the truth, they don't change their minds, that's not what I mean, a lot of provisos, but that's not what I care about. But right now, this idea of hearing confidence intervals gives you estimates that are far more accurate and give you a degree of confidence than just saying a number. So if I give you a 95% confidence interval, I am telling you I am 95% sure that this answer is somewhere in here. Will I always be right?
No.
No. How often will I be wrong?
5%.
5% of the time. Well, why don't I go for more than 95% confidence?
Because there's
To
outliers.
go for 99, but I don't want to be wrong 5% of the time. Well, if you want to be confident to a higher degree, what's going to happen to your interval?
It's going to shrink.
No, if you want to be more and more confident,
Oh, yes.
you have to widen. I don't want to widen the interval. So you have a choice. How wide is the interval? How confident do you want to be? In this life, if you're right 95% of the time, you're doing damn good. So you'll take 95. Yes, in the back.
Why 196? Where is that through to come from?
Okay. Where does the 1.96 come from?
It's the formula, right?
Yes, it's a formula. But where did the formula come from? Right? Now remember, I told you the rule of thumb. The rule of thumb is that within one standard deviation of the mean, you have how much?
90%?
No. 68% of that is within one standard deviation of the mean. Within two standard deviations of the mean, how much do you have?
95. So you're trying to
You have
find
95.
more?
Correct?
Yeah, so you're trying to get outside of that basically?
Now, excuse me?
Are you trying to get outside of that 95% basically with that?
So if you have, if you're 95%, within two standard deviation, you get 99%, right? Correct?
3.
Within two standard deviations, right, you'll have 95% of the data, right? I'm sorry, I can't draw a picture on the board here. Right? You know what a normal distribution...
Right.
I know, but I want them to see also. Okay. The normal distribution, right? Here's a normal distribution. It goes from your point, this is the highest point, this is right, it goes from here, you're looking in this direction, right? Going up and coming down. The middle 95%, right? What I'm saying, I want 95% sure, that means I'm allowing 2.5% that is under what I'm telling you, and 2.5% that is over what I'm telling you. Is that right?
Yep.
Right? Now, if there's 2.5% above this side, is that right? And 2.5 on that side, right? That's two standard deviations. There's the 1.96. Well, the 2 is a more of a is an approximation. 1.96 came from two standard deviations.
The 95%. roughly.
1.96.
The middle 95, here, again, here is your normal distribution.
But why not 95?
Here's your normal distribution. The mean is right down the middle here, right? Here is the middle. Within 2 standard deviations on either direction of this, you have 95% of the data. That's 1.96. If I wanted to be, if I wanted to be 90% sure, wait.
The actual number.
Excuse me?
That's
The one that we got the actual
95% interval.
That's where the 1.96 comes from.
1.96 means 2 standard deviations.
Do it on Excel, look up a table.
Correct. No, wait.
Because that equals 95%.
Wait. I am going over now,
It rounds to that.
I'm going over
Yeah.
basic statistics.
whatever.
Statistics that you had to take, that you answered questions on the pre-qual, but you probably didn't understand what you were doing, you were just writing them down. Okay. Let me show you. Let me demonstrate this. I'll show you exactly what I mean. Here. Let's get rid of these people's names so I don't have to see their names. Okay, these people did what I asked you to do. I asked you to do a sample of size 100, right? I'm sorry, it's 400. I asked them to do a sample of size 49, 100, 400, 900. Why did I choose such strange numbers?
They're like perfectly square.
Why did I choose these numbers?
Yeah, because when you do the
Squares.
end part, it's easy.
Because the confidence interval will require taking the square root of n, so I picked the number n that you have an easy square root. Okay, here is 15, and how many people do I have here? From 4 to 17. That's 14 people. I have 14 people did a random sample of size 49, right? Not of size 400. And these are the answers that they get, right? Got an answer as low as 88, I'm sorry, an answer as low as 25, and an answer as high as 208, right? Then I asked them to take a sample of size 100, same people, and they took another random sample. Now they took a random sample of size 400. Now they took a random sample of size 900, right? So I have 14 answers from different, different people for 49, 100, 400, and 900. Okay. The mean of all of these were all their answers. The average of everything they gave was 106.94. What's the correct answer? 111.
111.
Pretty close. The average of all of the 100 was about 114.1. The average of the 14 for the 400 was 190, right? Was the average of everybody in the ballpark? Yeah, 111.50, right? But within each group, there are some people who gave terrible answers, right? Everybody see that? Let me just finish the idea. You see that?
Yeah.
I then took a standard deviation of their answers. They averaged 106 with a standard deviation of 44, right? This group, the same group of 14 when the size was 100, got an average of 114 with a standard deviation of 24.97, 12.94, 9. What's happening to the standard deviation of their answers?
Decreasing.
They're still giving me different answers, but the range is shrinking, right? Theoretically, I can tell you in advance what it should be. These are not individual profits. What are these? These are not individual profits, right? These numbers are not individual profit numbers. What are they? The average of something, right? An average based on 49, an average based on 100, right? These are all averages, correct? The distribution of X, these are X bars. This is called X bar. These are all X bars, the little x with a bar on top. These are estimates. The mean of X bar is equal to the mean of X, the same as the original. And you saw that because they're all close to 111. The standard deviation of X bar is sigma divided by the square root of n. So as the n goes up, the standard deviation of this list goes down. This was the actual standard deviation based on what I got. This is theoretically what the formula says I should have, sigma of the square root of n. How close was I in every single one of these?
Relatively well.
Relatively? Should have been 909, I got 969. And by the way, I can't guarantee everybody here did it correctly. Look how close they were, right?
Very close.
Whatever Talib is going to say. Are these numbers pretty close to target? Absolutely. So let's take a look at the formula again.
Excuse me.
The formula, well, I'll beat you in a second. The formula here is the sample mean plus or minus 1.96 times sigma over the square root of n. This is the standard deviation of x bar. Sigma is the standard deviation of the individual profit. This is the standard deviation of x bar. I'm assuming this follows a normal distribution, because by the central limit theorem, anytime n goes over 30, the distribution is a normal distribution. So I take this number off the normal distribution table, and I can easily calculate it for anything you want. Most times when we do confidence intervals, we do either 90, 95, or 99. For 90% confidence would be 1.64. I'll show it to you. 95 is 1.96, and 99 confidence is about 2.58. Okay? That's the formula. Now, let me just finish one more thing. I wanted to do this with your numbers, not with somebody else's numbers. Okay. Now let's take a look. Here's a person who had 25, right? This is a person who took 49 items, right? This is a person who took 49 items and ended up with an average of 20.82, right? Give me his 95% confidence interval. His 95% confidence interval is 25.82, right? Go ahead. Plus or minus how much?
1.96.
Plus or minus 1.96 times
30.
272 divided by the square root of 49, which is 7.
Where'd you get your standard deviation?
Where'd you get, yeah, 272?
Okay. 272 is the actual standard deviation, but you know what? You're right, I shouldn't use it. What I'll use is the standard deviation that he calculated.
272 is the standard deviation for everything?
Just 1 second.
30.
Here.
1,000.
He calculated a standard, his sample calculated a standard deviation of 157.86. So I'll use his standard deviation. This is, right? Again. This is the mean that he got from his sample of 49, and this was the standard deviation he got from the sample of 49, right? So I'm going to use his 157 over there, okay, instead of the 272, because the 272 required knowledge of everything. Okay, so that's it goes for us. Let's do this. So, it's equal okay. His 95 confidence interval would have been from minus 18,014 cents to 69.78. Would he have been right or wrong? Huh? You would have been wrong. The correct answer is 111.50.
Oh,
Right? Turns out of this entire list, about 2 or 3 are wrong.
but you said 25.82. What's
Excuse
that?
me?
25.82.
Where I got that?
Yes.
Because that was the number he came up with.
That's 49 samples. Each one of these is 49 samples.
He took a sample of size 49. he got a mean of 25.82. He had a standard deviation of 157.86. From that, I construct a confidence interval, and it ends up his 95% confidence interval is wrong. I think of the entire list, he's probably the only one, or maybe only one of two that's wrong. Which is fine, because 1 out of 14 is 4 or 5%. Legitimate. So when I say, when you do it this way, some of you will get the wrong answer. Not because you did anything wrong, but because the technique built in says they'll be wrong sometimes. Okay, yes.
On which Word document was that formula in? Because I couldn't find it.
Right there.
Topic 4?
Yeah, topic 4.
No, sorry.
Right under the, right under the first, this is page 2, right at the beginning, up front.
Okay. Yeah.
Bottom of the page.
But it was farther down there.
Right near the bottom of the page. Right? Okay, again, what I'm trying to demonstrate to you is the larger the sample size, the tighter the distribution. And you can give me a confidence, and when I say I'm not, so if I have a class of 30 people, right, and each of you give me an answer, and you do a 90% confidence interval, how many wrong answers more or less should I get?
How many people?
How many people?
If I have 30 people in the class, and everybody did the assignment, and you got me a 90% confidence interval, how many of those confidence intervals would not contain the correct answer? About 3. About 10%. That's what I wanted to demonstrate to you. If I did a 95% confidence interval, right? 1 and 2 wouldn't be correct. 99, almost everybody would be correct.
So are we going to assume that in the test you're going to give us a 95% confidence interval, so we don't have to search for the z-score?
If I ask you to do 95% confident, this is the formula you use. I have to give you a mean and a standard deviation. The rest of it is just plug it right
I
in.
guess my point is, will you give us a different confidence interval? Because the
No,
z-score...
the only ones, I will post the mean for the confidence interval 90, 95, and 99. The only difference between them is the coefficient of the sigma. It's 1.64, 1.96, and 2.58. Otherwise, they're exactly the same.
I just want to come back to the 25 data that's written
Right.
as mean. You
Right.
just mentioned it's the mean, average mean? Or
The mean, that's the average profit that a customer generates.
Wow. Okay. So
He took 49 customers. For every customer, how much did that profit did that customer generate? Took the average, turned out to be $25.82.
So how do you find it? For example, it's a software I know, but you went through a lookup function.
You're looking for, right? Yes.
Can you come down a little bit on the sheet? Just down to the, below the mean? What is, that says D right there, that's 44,966.
The standard deviation.
But you used one.
This is the standard deviation, look at the formula, based on the different numbers that people gave me, right? I got 14 different answers
that's
from
the
different
standard
people.
deviation.
I actually calculated the standard deviation.
Oh, that's-
Theory tells me it should equal to 272.64 divided by 70. Theory came out to be very close to the correct answer.
And how does the other standard deviation, which was 150 something? 156?
Because here, what am I dividing by? It's sigma divided by the square root of n. This has an n of 7, this has an n of 10, this has an n of, I'm sorry, it's 49, so it's divided by 7.
Oh.
This is 100, it's divided by 10. This is 400, it's divided by 20. This is 900, it's divided by 30. Right? And it's corroborated. This is what theory tells you, and here is what 14 people who did it randomly. And again, I can't guarantee everyone did it correctly, but this class totally had about 30 people. I threw out the other 16 because I didn't
Where
like
do
what
you
they
get the
looked like.
157?
Excuse me?
For the 25.82, where do you get 157 standard deviation? That was over on
Because in this column I listed their mean, and this column I listed what they gave me for the standard deviation.
That's my question. Where do
Yeah.
you get 157 standard deviation?
He took 49 people, and he calculated the standard deviation of the 49. That's his estimate of that. Standard deviation estimates are usually much more accurate than mean calculations. So if you're taking a sample and you don't really know sigma, you use the standard deviation from your sample.